So let's talk about all the electric stuff for our temporary power and basically what's all this madness. With all the mechanical stuff taken care of, let's talk electrical. So let's begin with the ground rods. You actually saw us install a couple of them, but I actually made a mistake on them. They need to be installed at least 6 feet away from each other, and they were installed about 4 feet away from each other. So that meant that we had to install a third one that you are seeing us or saw us install, and that's meeting code now by installing it at 6 feet apart from each other. You can install as many as you want, but the minimum is 2 at 6 feet. So the inspector actually taught us a lot of very useful information. So now we know the difference between permanent service and construction service. Our intention initially was to use that stand to be the permanent service, and it will be the permanent service, but really the difference between construction and permanent comes down to a receptacle. So basically what we're going to be doing is we're going to be installing the meter panel over there, surge protector, but if we add an additional set of breakers and put a receptacle within that stand, that makes it a construction service. So we can pass inspection on that work alone, and we don't necessarily have to run all the cabling, power, set up breakers in the house to have the permanent service. So that's the difference, and that makes a huge difference for us because we can get that inspection taken care of, get power on site as soon as possible, and then we can take care of all the electrical services once the framing is done. So the inspector actually pointed out something very, very useful for us, and I'm kind of glad that, I guess, it's going to take a little bit of work, and the reason is we would not be passing inspection as we are because we would be bringing electricity directly into the house. We were thinking that by having the disconnect on the stand by itself was sufficient, but that would not pass code. We need to have an electric disconnect on the structure of the house, which is not the same structure as the one that's holding service meter. So that said, the reason for that is actually safety. So for example, the fire department can come in, they know where to find that there is a disconnect within the structure of the house, and then they shut off power. So we will have 2 disconnects, one on the structure, one on the service stand. So what we'll have to do is, unfortunately, we'll have to excavate right here. We will have to cut the conduit, then take here a 90-degree turn, another 90-degree turn, and then we will put a switch disconnect alone right here that we will try to embed onto the exterior insulation so that it's as nice looking as possible. From there, given that it's a single switch, we'll have to go back into the underground, come around, and then finally go into the mechanical room. The reason for that is we only have 1 hole for the service on the foundation, and we're not planning to make another one, so that's the plan. And the inspector said it was okay to do it. So. In order to get our temporary service inspection taken care of and passed, hopefully, we basically need 3 things: the main panel, a breaker, and an outlet. I'll be talking about this guy in a moment. So we're getting a 200 amp service, and anything above to the main transformer is the responsibility of the electrical company. This is where the meter will be, and once they come, we get approved. They will come in, set up a meter, and lock it. Actually, I will not be able to get in here. Now let's talk about the panel itself. In newer electrical codes, I believe it's in 2024 and future, you are required to have a surge protector on your main panel. We are actually on an older electrical code on this construction, but we're still adding it because it's a good idea. And it's even a better idea to add 1 of these to every sub-panel. So we will be having basically 1 of these on every sub-panel. Next, I want to talk about the main panel. And there's this thing called ground bonding, which means that you connect the the earth, I guess, the earth cable to your neutral. And you only do this at one location, and that is at the very, very first panel coming from the electrical company. And so that means it would be this panel. Typically, you get a green screw, but in this case, it's all embedded into the panel, and they already connected everything into the panel, so we don't need to worry about that stuff. But when you go onto any sub-panel, make sure that you do not connect your neutral to the ground, because that could cause problems and could be dangerous. So here's our outlet. You might see that it's definitely not an outlet. We decided to go a little bit extra so that we could make this temporary service a little bit more useful into the future for the house. So we ended up purchasing this box that's already pre-wired for RV stuff, and all of these breakers are 60 amp total, and we have a few different outlets. We can hook up an RV equipment and whatnot, so that's why we ended up getting this right here. And we are basically treating this box as a sub panel, so that's why we have on this side a 100 amp breaker running number 3 wire and the number 4 grounding cable, and then it's all going through this little conduit. So with this, we're ready for inspection, so fingers crossed. Inspection morning, so let's hope this goes well. Well, the inspector came, and unfortunately, we did not pass inspection on the meter. To be honest, the two issues that he mentioned are very, very simple, and we could easily change in like 10-20 minutes at most. So the first issue is that in this panel that we actually purchased off the shelf that was supposed to be working, this breaker doesn't have a GFCI, and it's intended for outdoors for the 240 volt RV outlet. So that's a very easy change to make. The second change that the inspector didn't like was this PVC tubing, I guess, is not properly fastened. It's a little bit loose, so he suggested that we basically do a better job at holding it in place. So that's also a very easy thing to do. But finally, he also mentioned that we could have a bigger problem, and that's related to the meter. And that's because electric companies, some of them, so you should check on that if you ever do this, they require you to have a meter jaw bypass with a lever, at least for us. And it turns out he was correct. And we do require one, and this meter does not have it. So that means we're going to have to replace this entire panel and have a new one. So that's really the bigger problem, not so much the inspection. We could take care of that any moment. So yeah, we're going to be replacing that, but I mean, we're doing this, so we might as well take advantage of these little changes, and we're going to be adding a generator transfer switch. So let's get to work, and I'll talk about it when we get it going. So right as we thought we were ready for inspection and getting our temporary power, the energy company, Xcel Energy, came over. They took a look at this and they said, oh, you're missing one more thing. So yeah, we're not there yet. So I'll show you what we're missing after I give you a quick tour of our new setup. So let's begin with this guy. This guy is the meter. And this little lever is the reason why we had to destroy everything else that we did before. This lever basically shorts both hot lines, and then the neutral is already shorted. And the reason for this lever to be is so that you can easily remove the meter without any sparks, and it's safe and all. One thing is, it's also required that this lever sticks out when it's shorted, so that they can tell that you're not stealing power, I guess. Not that we would, but anyway. But because we had to rework absolutely everything, we decided, okay, why don't we just add an additional automatic transfer switch to have a generator when we lose power, because typically when you lose power is basically when you need it the most, right? So we're going to have a generator that we don't have yet. So that's why we purchased this Generac automatic transfer switch. As you can tell, it's a 200 amp service, 200 amp automatic transfer switch. Utility service disconnect, that's what this is. It's intelligent enough to determine, okay, I lost power from the utility, so I'm going to automatically transfer to the generator, and then it turns it on, and then the house gets electricity from the generator, and then when power is restored, it transfers back to the utility. So that's the main purpose of this. But also when I was looking as to how these things should be connected, I could not find any information. So unfortunately, I had to like purchase it, open the manual, read the instructions, and that's the only way I was able to find out how this thing is supposed to connect. So I'm going to tell you so that you don't have to read the instructions, but you probably should read the instructions. So let's begin here with the utility. So we get our 3 main cables from the utility, 2 hots, 1 neutral, 1 ground. We come over along the lines, and then these cables, they are 03 cables, copper. They connect up here at the top. So this is where we get the power from the utility, or at least the meter. Next, where do you hook up the generator? So the generator will hook up in these 2 leads. There's actually a sign back there that says upper generator, lower load. So the upper, these ones are the generator, and these lower are the load, which basically means the house. So these 2 cables right here, the load, they go to our now new main panel, and then obviously they go around and connect at the top. I had already mentioned this, I'll mention it again real quick. This is a surge protector. It is required in new codes. In our code, construction permit, we don't need it, but it's a good idea to have it because it protects equipment. We also changed this panel, as you can see. So while I was changing it, I figured, why don't we make it an automatic pass-through so that we can send the load, the electricity, directly to the house. So that's effectively what this does. So you hook it up here, and then you have these 2 leads at the bottom, and then these are where we'll connect and go underground all the way to the house. Finally, you see this breaker, that's for the surge protector. This is a 30 amp breaker. And then we have a 100 amp breaker that I had mentioned before, and this 100 amp breaker is for our temporary power that is over here. So here was the second sore point where we actually didn't pass inspection, and it was related to the RV 240 volt outlets. The problem was that the breaker was not a GFCI breaker and the outlet was not a GFCI outlet. So that's why we didn't pass inspection. But then we thought, okay, do we really need that outlet? So we said, no, we don't really need it. So we decided to remove the breaker and cover the outlet. The reason we didn't want to add it is because when I started looking at breakers, the breakers were super, super expensive. They were probably more expensive than the panels. So I said, you know what, forget it. We might never use it. So if we do one day, then we'll just add it. Okay, so now to finish off, the problem that we're still missing, and it'll become apparent when we do it. So I'll just mention it quickly, and then you'll see us do it, and then I'll talk about it again. So the requirements from the energy company is to have a disconnect in between the meter and the transformer. And that's for safety reasons. That way they can connect here or whatever. And then once that switch is in place, we should be able to get our inspection. That switch is also temporary. And once we have a permanent power, we'll have to remove it. And then the electric company will hook up to it directly. But yeah, let's get it done and then I can talk about it. Well, this week we got our inspection again, and we finally passed. You have no idea how amazing that is. This episode has been going forever, but anyway, let me talk to you about what I mentioned I would talk about, and that is this disconnect, this switch. This is basically a switch that's sitting in between the transformer and the meter, and we're not connected right now, so I can definitely touch right now, and it actually feels good that I can touch right now. Anyway, so the point of this switch is so that the electric company can come, disconnect, and then they can put the meter without any electricity running through it, and you don't get any sparks or anything, and it's fully safe. Once we get the permanent service, which will be approved with all the breakers inside the house and everything, we will remove this monstrosity, and then they will basically just connect directly to the meter. So at some point in time, they will have to connect to this meter directly with electricity. So anyway, it's just a requirement. It's just what we gotta do, right? So Yeah, that's it. As you might have seen, this episode has been going forever. It's at least 2 years. I'm so excited that this is finally done. And so anyway, yeah, we're finally done with this episode. And we hope you like, subscribe, a minimum for our troubles or whatever. I don't know. Anyway, we'll see you in the next episode, and take care. Bye-bye.